Hello everyone, welcome to the Fluid Mechanics Lab. Here we'll be demonstrating the Pelton turbine characteristics experiment. There are three main objectives for this experiment. The first of which is to study the turbine characteristics curve at different flow rates at high head. The second objective is to study the turbine characteristics curve at different flow rates at low head, and the final objective is to study the effect of the spear valve alteration on the turbine's performance. To initiate our demonstration, I'll first take you through the apparatus of the experiment. Here we have our truss-free hydraulic bench. The hydraulic bench comes with a pre-installed pump that can be turned on and off using this switch, and the water going into the pump can be controlled using the inlet valve. To the side here we have the flow meter, which just simply indicates the volume flow rate. And of course, last but not least, in our hydraulic bench we have a ball valve, which can be turned on and off as such. Over here we have the protagonist of the experiment, which is the Pelton turbine. To its side we have attached a spear valve, which is connected to a pressure gauge, as you can see. And to the back of the turbine we have our braking system, which consists of the spring balance, and we have a clamping screw. And last but not least, in our braking system we have a pulley. And to measure the rotational velocity of the turbine, we will be using an external tachometer.
The experiment is divided into three parts. The first part fulfills the first objective, and to start off the first part we need to activate the pump and turn on the throttle valve, also known as the inlet valve, to run the Pelton turbine, as you can see here. We would then turn off the circulation of the water by dropping down the valve. Only then we can calculate the volumetric flow rate using a stopwatch, as you can see being done. As the first objective suggests, we need to perform the study of the characteristic curve at high head, meaning we should set the pressure gauge to get a relatively high reading. We can adjust the pressure using the spear valve, as you can see. In this case, we will set it at 1.5 bar, which should be maintained constant throughout the first part of the experiment. By setting the pressure to 1.5 bar, the rotational velocity reading should be between 1800 to 1900 RPM. As you can see here, we can measure it using an external tachometer. After doing so, we can proceed to taking the brake force readings. First, we tighten up the tensioning screw on the pulley wheel until the turbine is almost stalled. We would then note down the values indicated on the spring balance for it to be used as our upper limit. We will also note down the rotational velocity using our external tachometer. After doing so, we can then decide on a suitable increment in force to give adequate sample points. Ideally, 8 points between 0 and maximum. To obtain the data for the lower limit of braking force, which is approximately 0, we slacken off the tensioning screw, as you can see here, so no force is being applied to the turbine. We would then note down the braking force indicated at the spring balance, as well as the rotational velocity, which can be obtained using the external tachometer. After all that is done, we can tighten the screw to obtain our first increment of brake force. When the readings are steady, we can record them and repeat the process until we obtain data for 8 points ideally. The recorded data, which will be given in the dataset file, can then be used for analysis and to plot the Pelton turbine characteristics curve. As for what can be considered the final step of the first part of the experiment, it would be to repeat the procedure with a reduced flow rate. The flow rate can be reduced using the throttle valve, also known as the inlet valve. We would then repeat all the previous steps of gradually increasing the value of torque to collect the required data. While doing so, we need to ensure that the pressure is at a constant 1.5 bar, and that can be done using the spear valve. Repeating this step once more will produce a total of 3 sets of results for comparison. For the second part of the experiment, which fulfills the second objective, all we need to do is repeat the procedure of the first part, with the only difference being a low pressure head of 1 bar, as you can see here. For the third part of the experiment, which fulfills the final objective, all that needs to be done is to set 3 different positions for the spear valve and control the pressure using the throttle valve, as you can see. We would then repeat the procedure of the first part by taking the readings of incremental braking force for 3 different flow rates at a constant pressure head.
With that, we have concluded the experiment and gathered all the data we need to do all our calculations. Thank you very much for your attention.